Hello everyone, I'm Muskan, currently pursuing my bachelor's degree from Sri Venkateshwara College of Engineering in Computer Science Cybersecurity. Today I'm going to present the topic of recursive functions. In this video, we will learn about what is a recursive function, what are the two major cases of recursive function, types of recursive functions, advantages and disadvantages of recursive functions, and tips for writing the recursive function. So what is a recursive function? A recursive function is defined as a function that calls itself to solve a smaller version of its task until a final call is made which does not require a call to itself. Recursive function has two major cases, base case and recursive case. The base case is nothing but the condition that prevents the function from calling itself again, avoiding infinite recursion. The recursive case is the part of the function where it calls itself to solve a smaller version of the problem, eventually reaching the base case and completing the task. Let's understand this with an example. Let's say we have to find the value of 5 factorial. We know that 5 factorial is 5 into 4 into 3 into 2 into 1. But this can also be written as 5 into 4 factorial, where 4 factorial is nothing but 4 into 3 factorial. That means this expression can be written as 5 into 4 into 3 factorial. Similarly, this can further be written as 5 into 4 into 3 into 2 factorial, expanding further to 5 into 4 into 3 into 2 into 1 factorial. We know that 1 factorial is 1, therefore we get this expression. The takeaway here is that these three expressions are the recursive cases and this expression is the base case. As we have learned before, a recursive case is nothing but dividing a big problem into smaller problems. So 5 factorial is divided into 5 into 4 factorial, and this 4 factorial is further divided into 4 into 3 factorial. And this 3 factorial is divided into 3 into 2 factorial. 2 factorial is divided into 2 into 1 factorial. But 1 factorial is equals to 1, which makes this expression as the simplest form of the above expression. So this is the base case, as we cannot simplify it further. And these three other recursive cases. This is a C program for the same example. This code block here is a recursive call, and this is the code to break the recursion. Here we can see that if n is equals to 1, it will return 1. But if n is not equal to 1, it will return n into factorial of n minus 1. So if n is equals to 5, it will not return 1, but it will return 5 into 4 factorial. If n is equals to 4, it will return 4 into 3 factorial, and so on. This will keep on happening until n is equals to 1. Here, you can enter any number to get the factorial. So the factorial of 5 is 120. We can also see the factorial of 8 is given as 40,320. So what are the types of recursion? There are 4 types of recursion: direct recursion, indirect recursion, tail recursion, and non-tail recursion. Direct recursion. This is the most common type of recursion where a function calls itself directly. This function enters a new instance of itself during execution until a base case is reached, causing the recursion to stop. Here, the function calls itself for all positive values of n. So it is said to be directly recursive function. Indirect recursion. In this type, multiple functions call each other in a circular manner. In other words, function A calls function B, and function B calls function C. And eventually, function C calls function A, or function C calls another function that leads back to function A. This chain of function calls forms an indirect recursion. In this example, we can see that function 1 and function 2 are indirectly recursive as they both call each other. Tail recursion. Tail recursion is a type of recursion where the recursive call is the last operation in the function, allowing for efficient memory usage and optimization by compilers. Here, this is the recursive call, and this is the code to break the recursion. Here, return fun n minus 1 is the last thing done by the function, because after this recursive call, there is nothing to evaluate. Therefore, it is a tail recursive function. Non-tail recursion. Non-tail recursion is a type of recursion where the recursive call is followed by additional operations, potentially leading to increased memory usage and no tail call optimization. In this example, this is the recursive call and this is the code to break the recursion. The recursive call returns to fun n minus 1, but we have a print statement to evaluate. Therefore, it is a non-tail recursive function. Let's see some advantages and disadvantages of recursive function. An advantage of recursive function is its simplicity. Recursive solutions are often easy to understand and express the problem naturally in code. And a disadvantage of recursive function would be memory usage. Recursive calls may consume more memory, leading to potential stack overflow with deep recursion. Another advantage of recursive function is its complex problems. They can handle complex problems more elegantly, like working with trees or backtracking scenarios. Another disadvantage of recursive function would be its performance. Recursive functions might be slightly slower than iterative solutions, and tail recursion optimization isn't always guaranteed. Here are some tips for writing recursive function. Base case first. Always start with a simple condition that tells the function when to stop and return a result directly. It's like having a simple solution for the smallest part of the problem. Break the problem down. Think of a way to break the main problem into smaller, easier to solve parts. Then use the same function to solve the smaller parts. Watch out for infinite loops. Make sure that each time the function calls itself, it gets closer to the base case. If not, it may go on forever and cause problems. Avoid repetition. If the function calculates the same thing multiple times, try to remember or write down the results so you don't have to do the same work again. Conclusion. Recursive functions are a fascinating and powerful concept in C. They offer an elegant approach to solving complex problems by breaking them down into simpler subproblems. Embrace the beauty of recursion and its potential to create elegant solutions in your programming journey. Practice, learn from mistakes, and let the recursive mindset propel your problem-solving abilities. Thanks for watching.